All right, so today we are going to graph quadratic functions from factored form. But I need you to tell me, what are we always looking for when we solve any quadratic function? What are we always looking for? The x-intercepts. We are always looking for the solutions, the roots, the zeros, the x-intercepts, right? And what are the x-intercepts on a graph? They are the points where our parabola crosses the x-axis. So we are always looking to see, where does this thing cross the x-axis? So yesterday we started with, or last class we started with vertex form, where we plotted the vertex, right, that we pulled from vertex form, remembering to change that h to a different sign, right? And then once we did that, we used the 1, 3, 5 method, right? Where we multiplied our a by 1, by 3, by 5, if we needed to, 7 and 9. But we used that 1, 3, 5 ratio to help us get other points until our parabola crossed that x-axis. Does everybody agree? Yes? Now, what other method did we use? We put our vertex, and then what could we do? We could use either factoring or quadratic formula in order to find your roots, and then just plug those in and create your parabola, right? So today what we're going to do, we're going to graph again, but today we're going to graph from factored form, okay? So let's look at what we saw yesterday. Same thing that we're seeing today, because these things always hold true. If I am trying to find my y-intercept, what do I need to do? Plug in a 0 for the x. That is always true. It doesn't matter if you're dealing with quadratic functions, linear functions, absolute value functions. It does not matter. You can always plug in a 0 for the x to find your y. Everybody got it? Yes. The y-intercept. Now, what are our x-intercepts? These are actually our solutions, right? Now, in this formula, they are written as r sub 1, r sub 2. What do you think that r stands for? Root, right? But we've also seen them as x minus p times x minus q. It doesn't matter what letters they use, they all stand for the same thing. Is everybody following? Just like yesterday, when we are pulling a factor or pulling a number from here, we always take the opposite of what we see. Everybody got it? Yes. All right, now, our axis of symmetry is the same. What is the axis of symmetry? It is a line that goes through our what? It goes through our, it goes through the, yes. It goes through the vertex, but it also goes directly between the middle. It's the midpoint between your two roots, right? Between your two x-intercepts. So we had learned a trick a little while ago, right? We got a cheat code where we could do what to find that point? We could add the two numbers together and then divide them by what? By 2. We add our two roots together if we got them, and we divide by 2. And when we do that, that will give us the point that's in the middle. That will give us our axis of symmetry. What else does it give us? Well, if it gives me my axis of symmetry, it also gives me my x of my vertex, doesn't it? Yes? So then it won't be much to find my vertex, because all I got to do is plug that number in and get my y. Are y'all with me? I know what I'm saying is a lot, but I'm hoping you're able to follow me. We're gonna actually practice this out. And then my vertex is obviously my lowest or my highest point. It is my minimum or my maximum, depending on what my a is, right? If my a is positive, what type of parabola do I have? Is it u-ing up or u down? U up. So am I going to have a max or min as my vertex? Don't guess. Picture it. If I have a positive a, is my parabola going to u up or down? U up. And if it u's up, then am I going to have a max or min as my vertex? Minimum. Good. Just think about it. And then if I got a maximum as my vertex, then that means that my parabola u'd down, which means my a must have been what? Negative. Is everybody good on that? Yes. All right, let's jump right into this real quick. Let's look at this problem. You all should have this on the back of the paper that you had last class. So flip your paper over. Is this the same problem? No? Yes? Yes? Yes. All right. So what is this the same problem you have on your paper? Is it the same problem? The one I just gave you? Yes. 9.3. Everybody got it? Yes. All right. So Ricardo, I'm looking at this problem. What form of a function is this? What form? Is this standard form of a quadratic function? Is it standard form? Is it vertex form? Or is it factored form? Is this vertex form? No. How do we know it's not vertex form? What in here tell you it's not vertex form? What do we look for in vertex form? H and K, right? We look for, matter of fact, where's our vertex form? I don't think I have it on here. We look for this when it's vertex form, right? Oh, I'm doing it sideways, sorry. This is vertex form. We look for this H and this K, right? So how do I know what form that I'm looking at right now? This has H and K. How do I know what form this is? Well, for one, it says right here. What does that say? Okay. And it says here, what? So this is what form, class? It's factored form. All right. What does factored form give me? It gives me my what? It gives me my two what? My x-intercepts. Will I always have two x-intercepts? No. I may have one. I could have none, right? If this parabola never touches the x-axis, then I don't have a solution. I don't have an x-intercept. I do not have a root. I do not have a zero, right? But factored form gives us our solutions. Based off what we see right now, tell me what our solutions are for this particular function. What is my P and my Q? What are my two solutions? I heard +3 and -5. Raise your hand if you agree. Raise your hand if you disagree. Okay, what is it? You're supposed to take the opposite, right? Because the formula says y equals a times x minus p times x minus q. So if that is the case, then what should our roots be? Opposite of this is +3, so the opposite is what? It should be -3. And this is -5, so the opposite of that should be what? +5. So our two roots are +5 and -3. Does everybody see that? Let's not make that mistake again. Are we all good here? Yes? All right. So the goal of this exercise is to graph your parabola. So I'm going to go ahead and graph. And I'm going to start with what I know. I know that my roots, based off what we just figured out, is going to be x equals -3 and +5. Do we all agree? Yes. So can we plot those points? Where do I plot those? On the y-axis or on the x-axis? X-axis. These are my roots, my zeros, my x-intercepts. So here, do what I'm doing, because this is your example. Any questions? No. Now, what's the minimum amount of points that you need in order to graph a parabola? The least amount of points. Can I make a U with 2 points? Can I? If I give you 2 points, can you make a U with that? No. What's the only thing you can make with those 2 points? A line. So I'm asking you, how many points? What's the minimum number of points that you need to make a parabola, to make a U? 3. How many do I currently have? 2. All I need is what? 1 more. Now, the more points, the more accurate it's going to be, but as a minimum, all I really need is 3. Are you all with me? Plus, this thing is already solved, isn't it? Because what is the goal of solving a quadratic function? It is to find your, and don't we already have them? So that we've already solved this. We already got our solutions. Are y'all with me? Yes? All right, so, and then it says it right here, that we already have our what? Solutions. So, but we're going to graph this thing out completely. So I want you to help me find my vertex. What do we know about the vertex? What do we know? Where does it fall in relation to our other points? In the middle. So what did we say was our cheat code for finding that line that goes directly in the middle of these two? What do we do? Add them up and then do what? Divide by 2. Grab your calculator. What are we going to put in the calculator? What kind of 3 is that?
Negative.
Good. So -3. So 3 plus or minus. So we got -3. Then we're going to do what with that? Plus 5. And then we're going to press equal. What does that give us? 2. Now what am I going to do with that 2? Divided by what? 2. And what does that give me?
1.
So what does that 1 tell me? Where does that 1 fall in relation to -3 and +5? In the middle. Isn't that the reason why we did this?
Yes.
Aren't we trying to find what's the center?
Yes.
How do you find the middle of something? Don't you just split it in half? Yes? So what does -3 plus 5 give me? It gives me the distance, right? What's the distance between these two? And then I divide it by what? 2, and that's going to give me the space right in the middle of those two. Are you with me? Yes? All right, so I know now that this is my center, right? That's not one of my points on my parabola, but that is the center. So what does that tell me? That tells me that my axis of symmetry should go through here. Does everybody see that? Yes? So I'm going to erase this little dot. And this is my axis of symmetry. I can check it. Watch. How far is my axis of symmetry from my first intercept? 1, 2, 3, 4 units. Y'all see that?
Yes.
How far is it from the other one? 1, 2, 3, 4 units. So is it in the center? Yes. So my equation for this line is going to be x equals 1. Why am I saying x equals and not a y equals? Because it'll never touch the what? Y-axis, so I don't need a y in my equation. Are y'all with me? Our axis of symmetry is x equals 1. Does everybody follow?
Yes.
Any questions? All right, so right here we got our axis of symmetry. It is x equals 1. Now, that helps me out. Because what is our axis of symmetry? The equation is x equals h. And what does h stand for? What is the h? Where have we seen an h? In our vertex. What is the h in our vertex? The x. So now, guess what? I already have the x of my vertex. I already got it. So if I want that third point, watch this. I just need to figure out what my vertex is. Are y'all with me? I already know that the x of my vertex, because this is, I'm sorry, I'm going to use the letters that they use. This is HK. I already know that my HK, I already know my H is what? 1. So now I have to find my Y. Are y'all following?
Yes.
Yes? What am I going to do? Bless you. What am I going to do? Plug it in. That's what you do. That's what you do every time. If you give me the X, I'm going to plug it in to get the Y. If you give me the Y, I'm going to plug it in to get the X. That's how we do that, right? So let's plug it in. What are we going to plug it into? To the factored form. So what was the factored form of our function? It was Y equals. It was -2? Okay, times what? X plus 3 times X minus 5. Is this how it looked? So, all I have to do is plug in the X here and here, and it's going to give me the what? The Y. Are y'all following? So let's go. Y equals, Tiana, you with me? -2 times, what am I going to put in place of X? 1. 1 plus 3, and then I'm going to have 1 minus 5. I'm going to stop there for a second. Does anybody have any questions? Why am I doing this again? Because if we don't know why we're doing it, it don't make sense. Why are we doing it? To find what? What am I trying to find? The K. I'm trying to find the K of my vertex. I'm trying to find the Y of my vertex. Are y'all with me? Why? Because I'm graphing this thing and I need a third point. I already got 2 points, the 2 solutions. I already got the x-intercepts. If I get me one more point, I might be good to go. Are y'all with me? All right, so let's do it. Y equals 1 plus 3 and 1 minus 5. They are in parentheses. According to PEMDAS, what do you do first whenever you are trying to simplify? You follow the order of operations. What does the P stand for? So let's do what's in parentheses first. You do not multiply first. You do not distribute first. You do parentheses first. You simplify them. So what is 1 plus 3? 4. What is 1 minus 5? Negative 4. Y'all shouldn't be guessing. You got calculators or your brain? Give me something. All right, now I'm here. Now I got y equals negative 2 times 4 times negative 4. This is all multiplication. So we can just multiply from left to right, right? Grab your calculators. Tell me what you're putting in your calculator. First thing I'm putting is what? 2. How do we put that in? 2 plus or minus. Then what? Times what? 4. Times what? How you put in negative 4? 4 plus or minus. So what do we end up with? Positive or negative? How did I know just looking at this it was going to be positive? Because I got 2 negative signs. Absolutely. Are you all good there? Yes? So our answer is y equals what? 32. What does this 32 represent? The K, which is the y of my vertex. So tell me now what my vertex is. 132. Easy, medium, hard. Okay. All right. Now let's go back and plot that point. If our vertex is 132, we're going to go right 1. We already knew it was on this line, right? And then we're going to go up to 32. This is 30, 31, 32, 33, 34, 35. Now remember, this is going to be off just a tad bit. Why? Because we don't have all the lines on here, right? So we're kind of estimating where a point should be. But this is basically what our parabola should look like. Are y'all with me? Yes. But if I freehand this right here, right now, it's not going to look good. So let's use our 1:3:5 ratio to get more points. Are y'all with me? All right, so let's go over here to the side. Let's put A equals. And then we're going to put 1A, 3A, 5A. I'm going to even go and put 7A. What was our A? Negative 2. Now tell me real quick before we do this, because I don't want nobody just copying me. I want us to know why we're doing what we're doing. Why am I about to do what I'm about to do right now? Why am I doing this 1:3:5? Because I want more points, right? We already got 3, which is enough to make a parabola and enough to answer my questions, right? However, I want to graph this full parabola, and I know if I freehand it, it won't look good, right? So the more points, the more accurate I make this. So I am looking for more points. How can I get more points? I can either, 1, plug x's into my equation and get out y's, do a little t-chart, plot those points, and then reflect them. Or I can use the 1:3:5 method. Are y'all with me? Yes. So let's do the 1:3:5. What's 1 times negative 2? Negative 2. What's 3 times negative 2? Negative 6. What's 5 times negative 2? Negative 10. And what's 7 times negative 2? Now, what are these numbers telling me? That I'm going to go right 1, and then I'm going to go what? After I go right 1, then I'm going to do what? Down. I'm going down what the first time? Down 2. Then the next time I'm going to go right 1, and then I'm going to do what? Down 6. Then I'm going to do right 1, and I'm going to do what? Down 10. And then I'm going to do right 1, and I'm going to go down 14. Are y'all with me? Every time I go down, after I finish counting, I'm going to put a point. Are y'all following? All right, so let's go back to our vertex. It's right here. This ordered pair is 132. Get your calculators ready. What is my first move? I'm going to go right 1 and then down what? Down how many? 2. Do y'all know why we did this? So why don't I hear you? This is down 2, down 6, down 10, down 14. Always go right 1 and then go down, right? If it's negative, we go down. What if they would have been positive? We go up. So I'm going to go right 1. I need to go down 2, but I'm at 32. So in your calculators, just stay with me. In your calculators, put 32. And then what we're going to put? Minus 2. And where does it tell us to stop? 30. So I'm going to go right 1 and down to 30, and I'm going to put a point. Now this ordered pair is 2, 30. I just took care of that first one. Now, we're at 30. What's our next move going to be? Right 1 and then what? Down 6. So in your calculator, it already says 30. Let's put minus 6. What do we get? 24. So I'm going to go right 1, and then I'm going to go down to 24 and put a point. So where am I now? I'm at 324. Does that make sense? All right. You see how I'm getting more points? What's next? I did down 6. So what's next? Right 1, and then what? Down 10. In your calculators, we're already at 24. We're going to go down 10. So what are we going to put in the calculator? Minus 10. Where do we end up? 14. So I'm going to go right 1, and then I'm going to go down to 14, which is right below 15. And so what is this new ordered pair? 4, 14. Does everybody see what I'm doing? Does everybody understand it? Yes? All right, and now we just did what, 10? Now let's do the next one. What's the next one? We're going to go right 1, and then we're going to go what? Down 14. Well, I'm already at 14. If I go down 14, where will I end up? At 0. And so now this one is what? 5, 0. Everybody good? Now I only got one side of my parabola. I need the other side of my parabola. So what do? I'm going to reflect. I'm going to use those points to reflect, right? So how far is, pay attention, this is important. How far is this point from the axis of symmetry? 1 unit to the right, so I'm going to plot a point. 1 unit to the left. Here, this is sitting on 24, but it's 2 units to the right. So I'm going to go stay on 24 and go 2 units to the left. Did I do that right? No. 2 units. 1, 2. Oh, and not on 25, on 24. Does everybody see that? All right, now my next point. This is on 14. It's 3 units to the right. So I'm going to stay on 14. I'm going to go 3 units to the left. And then we already got the last point already plotted. Everybody see that? Yes, so then we just do and we're done. Are there any questions? No? So let me bring life to this problem, okay? Let's say that this graph represents, it's a model of a situation. And let's say the situation is where, let's say, Woodley has a ball in his hand and he's throwing the ball. Are y'all with me? Yes? What happens with the ball? It goes up into the air and then it does what? Comes down. Here's a question. Based on what we see, how high up from the ground did the ball start? Think about my question. Look at your graph. How high above the ground did the ball start? Start. Where? What is your starting point? What is always our starting point? The y-intercept. So what is that? What is that in this problem? It's 0.30. Isn't that your starting point? Why are we thinking of something new? Why do we see this thing? We're like, I don't know where the ball started. If I'm asking you how high in the air, at what point, where was this ball when it started? When he released this ball, it was where? At 30 feet. How do I know that? Because that is the starting point. I don't care about all this other stuff. Remember what you know. This ball started at 30 feet in the what? Air. Here's how I know. First of all, because our y-intercept is our starting point, right? Also, because what is the time at that point? What is the time for this point? What is the ordered pair to represent this point? So then help me. If it's 30 feet, then what is the time? 0 seconds. At 0 seconds, the ball was what? 30 feet in the air. Are y'all following? Or whatever unit we're talking about, right? Here's another question. What is the maximum height of this ball? What is the maximum height of this ball? If you're telling me this ball started at 30 feet above the ground, what is the maximum height that this ball reached? What is it? It reached 32 feet. Why is it not 132? X is the what? It's the seconds. It's the time. 32 is the feet. So 0:30 means this thing started at 0 seconds before he did anything, before he released the ball. It was at 30 feet above the air. 30 feet above the ground. Then he let the ball go. What happens to the ball? You told me it goes up in the air. How do you know this is the maximum height? Because that's my vertex. Right? Where did this ball stop before it started to go down? At 32 feet. Here's a question. How long did it take the ball to get to its maximum height? 1 second. How do I know that? Because at 32 feet, it was 1 second that had passed. Are y'all following? Yes. How long did it take this ball to reach the ground?
5 seconds.
5 seconds. This ball was on the ground in 5 seconds. Are you all with me? Yes. Now watch this. What did we say our solutions to this problem was? What were our solutions? -3 and what? +5. Here's my question. Which one of these answers is not a viable solution? Which means which one of these does not make sense in real world context? -3. Can you have -3 seconds? So then guess what? None of this, watch this. If I was solving this, none of this would make sense to me. It's the math. It's the math. But does it make sense in real world context? Why doesn't it make sense in real world context? Because you can't have negative seconds. So what does that mean? That means that this thing started here and it went here and it went down. Still a parabola. Still a quadratic function. But the part that was over here is not viable. What does viable mean? Does it make sense? It doesn't make sense. Why? Because anything on this side is negative seconds. Are y'all following me? Yes. And can we have, Sinai, negative seconds? No. So what do I need to pay attention to? Only anything over here. Are y'all with me? Is everybody following? What about any points down here? Would that make sense? Any points down here below the x-axis? Why not? Because that would be negative what? Feet. Is the ball going beneath the ground? No. So does that make sense to have negative y's? No. So what part of this coordinate plane do I need? What's the only part that makes sense? What quadrant is it? Yes, the upper right. What quadrant is that? Quadrant 1. The only one that makes sense is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. What is the only quadrant that will make sense? Quadrant 1. Why? Because what's positive? The number of seconds and the what? And the feet above the ground. Are you with me? Ball can't go under the ground, so anything with a negative y don't make sense. And the seconds can't be negative, so anything to the left of the y-axis don't make sense. So the only area that makes sense for what we are doing is quadrant 1. Does that make sense? So let me ask again. At what point, not even again, at what point was the ball 24 feet above the ground? At 3 seconds. Does everybody see that? Yes. Where was the ball at 4 seconds? 14 feet what? Above the ground. Do you see how we read this? Do you see how we can use this to answer real world situations? Yes. Any questions? No? Everybody good? All right, so your job now, because I think we're done with answering our questions. We didn't answer our y-intercept. Let's do that. Y-intercept. What is the y-intercept for this problem? We can look at it and tell what it is. What is it? It's 30. It's 30 feet, right? If it's real world context, it's 30 feet. If it's not real world context, it's just 30, right? How do we write that as an ordered pair? 0, 30. Now, what is in place of the x? A 0. So now, let's say, for example, you didn't recognize that your y-intercept was 30, or you didn't finish graphing it. Can we find our y-intercept? Yes. All we got to do is plug in 0 for the... How do we find the y-intercept? We plug in 0 for the x. So let's write the rule out. Y equals -2 times x plus 3 times x minus 5. And we are now going to find the y-intercept by plugging in a 0 for the x. So we got y equals -2 times 0 plus 3 times 0 minus 5. Y'all with me? Yes. Then we got y equals -2 times 3 times -5. Does that make sense? Yes. Yes? Now we just do the multiplication. Grab your calculators. And what do? It's all multiplication. So we put 2 plus or minus times 3 times 5 plus or minus equals, what do we get? 30. Is that not what we already have? Yes. So that's how we find it. Are there any questions? No? Everybody good here? Yes. Great. All right. Ready to do this on our own? Let's try it.